Geometry Chapter 4 Final Review for the Semester 1 Final. We covered a lot of topics in Chapter 4. It was basically our triangle chapter. So we started off with just discussing congruent figures and their corresponding parts. Then we started to prove triangles congruent. We used SSS, SAS, ASA, and AAS. After that, we developed CPCTC, saying that corresponding parts of congruent triangles are congruent. Then we moved on to discuss isosceles and equilateral and a bunch of theorems about those. Eventually, we developed a fifth triangle congruence theorem called the hypotenuse leg. And then we just kind of started to talk about overlapping triangles and different things there. So we're going to do a review on some of these topics. We're going to start with the very first topic, that students will be able to recognize congruent figures and their corresponding parts. So here in this picture, we've got two triangles below. They're congruent. We're supposed to list their congruent corresponding sides and angles. So here you can see my markings now. They've appeared. We want to kind of start by just lining up the parts that are marked. So I've got this side AB with a 1 mark, and I've got this side over here ED with a 1 mark. So those are going to correspond. Now we want to be careful when we write our congruent statements. We want to line up those corresponding parts. So I notice that A has no mark on the angle and E has no mark on the angle, so they might go together. B and D both have a double mark, so they are going to go together. So it's going to go ED for my side. That kind of leads me into the angles congruence. I can see that B has the double mark, as does D, so those two are going to be congruent to one another. I look for any other marks. I see some marks on angle C and angle F being congruent, so I'm going to say those as well. Now, since this is a triangle, there's 3 sides and 3 angles in each, which means there should be 3 pairs of each. I've got 2 pairs of angles. It's pretty easy to come up with a third pair. They're the ones that aren't marked. Those are going to be congruent as well, so I get A and E. Now with sides, it gets a little bit trickier when they're not marked and there's no numbers like in this problem. You actually need to use the angles to help. So if I look at this segment AC, it's got a 3 mark and a 1 mark at the end. I want to find the other side with a 3 mark and a 1 mark on the end. So I can see that that's EF. So AC and EF are going to correspond. Now the way that, since I've written down AC, when I write down EF, I'm going to line up those angle marks to get the letters in the right order. So A's got a triple, E's got a triple, so they both line up in the first spot. C and F both have singles, so they line up together. And then I have my last pair of sides that are going to match up with each other. So I've got B, C, and then my next one should be D, F, if I get that order correct. It is important to try and line up your corresponding parts whenever possible as you write your congruent statements. So we discussed recognizing corresponding parts of congruent figures. We also did stuff like this in our problem. So it says that we are supposed to use the statement below, fill in the missing measurements for the figures shown. So I've got 2 pentagons. I've got shape and rocks. So shape's got 2 angles marked at S and at E. And then over here on rocks, it's got 105 and 127. Now you might notice some numbers. Those are side links we're going to use in a minute. But I find it easier to start with the angles. So the angles are pretty straightforward because they gave you a congruent statement here. We're just going to line things up in the same orders and then see which one has a number. So S, if I look, has 102. It's in the first spot and so is R, so those two are going to be the same. So I can copy that 102 degrees over. Then I look at H and O. H has nothing, but O has 105, so I'm going to bring that 105 degrees over. A and C, I can do the same thing. There's nothing on either of those, so I'm going to leave those 2 blank. P and K, K's got 127, so does P. And then E and S, E's got 113, so does S. So that's how we line up the angles. Then when we do the sides, it's a similar process, but we're going to look at 2 letters that are in a row. So like you might notice this 3 over here on SH. Well, S and H are the first 2 letters, so are R and O, so those correspond. So I just bring that 3 over and put it on RO as well. I notice that maybe next on OC I have a 5, so those are the second and third. H and A are the second and third, so those 2 are going to line up. That one's going to be a 5 as well. I look, AP and CK don't have anything, but then I see a 7 down here in the bottom. The 7 is on S, oops, wrong direction. On SK, so that's this last 2 letters, so those are going to go with PE, so that's going to be 7 as well. Then I actually notice that over here on SE, I've got a 4. So it's S to E. Well, I'm going to do R to S. That's also going to be 4. So I came up with all these different angles and side measurements, basically just because I knew these shapes were congruent, meaning all their parts are the same. So after we discussed our first topic, we moved into discussing proving triangles congruent, using ASA, AAS, SAS, and hypotenuse leg. And so actually what I'm going to have you guys try to do is you're going to look at these 4 pictures and see if you can identify what those triangles are congruent by. And they may not be, so you can also say that there's not enough information. So pause the video and try these 4. Alright, you can see my answers up there. For the first one, I said that there's not enough information. That's because we have to have either the third side or an angle. So you need to know something about this side here or this angle that's located here, but we don't, so that one's not enough information. The next one is hypotenuse leg. This is the one that everybody forgets about. Remember, hypotenuse leg has 3 criteria. First is that they're right triangles. Second is that they have congruent hypotenuse, and third is that one of their sides is the same. So that's why those ones are going to be congruent. Next, we get into this bottom one. A lot of people see this one immediately and they go, oh, it's side, side, side. But if you actually look at the side measurements, it's not. So in this triangle over here on the left, it's got 2 double marked sides, but on the right triangle, it only has 1 double marked sides. So these ones are actually not going to be the same. And on the last one, a lot of people see that. They see all the angles match up. So I've got a 1 here and a 1 here, a 2 here and a 2 here, and then a 3 here and a 3 there. And they go, oh, they're congruent. Except there's no angle, angle, angle theorem. That one's not enough information. We're actually going to talk about second semester how those triangles are similar, but they're not necessarily congruent. Okay, so then what I want you to do next is to draw and label 2 triangles that are congruent by angle, side, angle. So try this one on your own again, and then you can check with me. Here's one example of what your triangles can look like. They don't have to be exactly the same as mine. The thing that you do have to have happen with angle, side, angle is that side has to be included, like right here, that has to be included between those 2 angles. It's got to be the side that connects those 2 angles on both pictures. Alright, so after that, this was our really big proof chapter, so we got to do some proofs. So students will be able to use triangle congruence and corresponding parts of congruent triangles to prove that parts of 2 triangles are congruent. So if you're kind of taking that apart, we're going to prove that parts are congruent. We're going to do CP-CTC proofs. But remember that in order to do a CP-CTC proof, you first do a triangle proof. So remember that there are 5 ways to show a triangle congruent. You can go ASA, SAS, SSS, AAS, and hypotenuse leg. So we're going to have to show one of those. We start our proof like you guys know. We copy down that given. So angle KBC is congruent KBC is congruent to angle ACB, and angle K is congruent to angle A because it's given. So you already know that information. We're looking for another piece of information we can then draw from the picture or from the givens. I typically go to the picture first. You can see that in the middle they share this side. That's going to be congruent to itself. So I'm going to say that BC, and careful on this one, because if you notice those triangles are kind of tipped and like twisted. BC is going to be congruent. See if you can fill in that blank on your own. It should be to CB. That order should change by the reflexive property. Something's congruent to itself. So now we've got that. If you look, we actually have now sent 3 pieces of information. An angle at K and A, an angle at B and C, and then a side at BC. That's enough order to give us angle, angle, side. So we're actually already prepared to say these triangles are congruent. Now when you put your order in, here's the trick that I've learned. If you have a statement that says angles with 3 letters, it already has all the parts lined up. Change the symbol of an angle out in front to a triangle and copy down the order of letters. And all your corresponding parts are lined up. And that's going to be by angle, angle, side. And so, remember the whole goal of this was to prove that KB and AC are congruent, so to show that this side here is congruent to that side. Well, we can now say that they are. KB is congruent to AC, and that's due to our CPCTC up there at the top. CPCTC. Okay, I hope this is coming back a little bit of a refresher for you. I'm going to have you guys try to start this proof on your own, see if you can finish it. It's another 4-stepper. So get that given in and see if there's anything else you can add. Alright, I got a good start on it. I copied down my givens, hopefully you've done that as well. And then I noticed vertical angles there in the middle where they cross and make that X. So I'm going to use the vertical angle theorem in my reasons, but in my statement, I'm going to name those angles. Now the biggest mistake I see is people try to name those angles with one letter. You have to use 3 because 1 is too vague. So I'm going to call this one here on the left, angle CAB. CAB. And the one over there on the right then is going to be EAD. Now if I look at that, I have a pair of sides up here and here, another pair of sides on the bottom, and then a pair of angles between. That's already your side angle side triangle congruence. So we're ready to say those triangles are congruent. Now because I was careful in statement 2, I can just copy down those letters but change the symbols out in front. And remember, the whole goal was to show that, hey, C and E are congruent, those third angles in the picture, or second angles in the picture. So now I can say, hey, C is congruent to E. Do you guys remember the reason why? It should be CPCTC. And other corresponding parts of congruent triangles are congruent proof. So, lucky for you, we don't have another proof after this. We're going to move on to our next objective, that was students will be able to use and apply properties of isosceles and equilateral. Remember that isosceles means 2 sides are congruent, and equilateral means 3 sides are congruent. There's a third type of triangle where no sides are congruent. People tend to forget that name. It's called scalene. Okay? So, we're supposed to start this problem by trying to find the value of x. We're given 54 degrees in this picture, and we're given some congruent marks here and there. Now this 54 degrees is referring back to that angle A. It's kind of hard to tell that. So if you notice, this is an isosceles triangle. A, B, and BC are congruent. And up here at angle B, you can see it's bisected. There's this lovely theorem about isosceles triangles that says, hey, if you bitex the vertex, which B is, then you're also a perpendicular bisector of the base. And I bring that up because that means that's 90 degrees. Now this is isosceles, so 2 sides are congruent. As are 2 angles, I can bring that 54 over to this angle as well and know those are the same. The purpose behind that might be to make myself this nice triangle here. I've got a 54 degrees at C. Up there at D, I can bring over a right angle as well. Well, I'm just looking for X, that top angle. You should know at this point in the year that all the angles in a triangle add up to 180. So I'm going to add the 2 I have, 90 and 54. I get 144. I subtract that from 180, and I get 36. X equals 36. So make sure you're looking for those triangles when you have angle measures. Try to set up a 180 relationship when possible. There are 4 triangle problems right now. It just says find the missing values in the triangles below. I'm going to pause and see what you guys can come up with. See if you can come up with all the sides if possible and all the angles if possible. Alright, I have all my answers written down on there. I'm just going to talk through them real fast to explain them in case anybody's stuck. On the first one, I'm going to talk about those sides to begin. You have 6 feet, and then you have a congruent marker on both of those legs, which means they're both the same, so you can bring over that 6 feet. And then if you notice, since that's an isosceles triangle, 2 sides are congruent, the base angles are congruent. So over here I have 30, and over here I have 30 again. Then I use a 180 relationship to go take 180 minus 30 minus 30, and I got that top angle to be 120. Now, this problem is specifically on here to make you think about the fact that pictures are not always drawn to scale. That top angle, too, does not look like 120 degrees, but it is, because mathematically that's what it is. So keep in mind that pictures may be deceiving. On this next one, we come over here, we once again have another isosceles. We've got congruent sides, meaning both of those are supposed to be 3 meters, which means angles 1 and 2 are going to be the same. So I started by subtracting that vertex of 112 from 180. I got 68 here, and then divided that by 2 to get that 34 degrees for each of those base angles. The bottom two are interesting. On this first one, you've got 3 congruent sides, which led me to say that all of those are 5. And that means it's equilateral, and so if it's equilateral, it's equiangular. I got 60 because, well, if it's equiangular, you have 180 degrees split between 3. So each one is 60. Now when I move over to the next one, I like this question a lot because they kind of start by telling you that you have 60 degrees for this top angle and that those bottom two are going to be the same. Well, if that leaves you with 120 to split evenly, those are both 60 then. Which then leads you to say, oh, all 3 angles are the same, it's equiangular, meaning it's equilateral, all 3 sides are going to be that 7 centimeters as well. Alright, that was the end of the Chapter 4 Geometry review for the final.